Okay, so moving on with the limits unit in calculus, one of the topics is infinite sequences. And this is helpful as we move on and see that idea of dividing by zero or dividing by infinity, where we're going. So when you're looking at a sequence, it is looking at a number of terms, and as those terms increase, we want to know what number is going to be reached. Like, what number are we tending towards? So when we're looking at that, here's our first example. So we have terms and our formula is 1 over n plus 1. So the question here is, what are our first three terms? So if we plugged in 1, we'd have 1 over 2, or a half. And if we plugged in 2, we would have 1 over 3. And if we plugged in 3, we have 1 over 4, and it keeps going. So when we're looking at this, we can see that even if we divided it, our number is getting smaller and smaller. If you graph it, like the second one is asking, and you plotted your points, starting from a half moving down to 0, we're starting to see from our first term, you would have exactly a half if this was a half, and then it gets smaller and smaller and smaller and smaller and smaller and smaller, and it gets close to the line of 0, but it never touches it. But what we can say is that our limit, as your n value heads towards infinity, meaning this is going on and on and on, that we are going to tend towards 0. So another question coming up is taking a look at a limit, and when your value is getting close to infinity, how can we tell what's going on? So if we have a question like what we're seeing here, where you have 2n cubed divided by n cubed plus 1, there is a note here that we can simplify this by always dividing all your terms by the highest power of n. So I'm going to take a look, because we're not going to change anything, but if I take my 2n cubed and divide it by n cubed, and then in my denominator take my n cubed divided by n cubed, plus 1 over n cubed, what we can see is in the numerator that we're left with just a 2. In the denominator, when we have anything divided by itself, you're left with a 1, and then you have 1 over n cubed. So as we're going through this, and like we saw in that previous example, as your denominator value gets larger, and that is what's happening here, right? Even though we're not seeing 2, 3, 4, we're going to be seeing bigger numbers, like going by the cubes, like 8 and then 27 and so on, but the denominator numbers is getting bigger. So as we increase the amount we have, the fact that the denominator is getting bigger, this whole term will tend to 0. So we can essentially take it out, and we'd end up with 2 over 1, which would just be 2. So the limit as n tends towards infinity of our equation will be 2. Our numbers are tending towards 2. As always, I hope you found this helpful. If you did, please subscribe. If there's any other video I can do for you, just let me know. And if you're taking chemistry, please check out my chemistry videos as well. Thanks for watching.